There is a place in China where the road disappears, not into a tunnel, not into fog, but into open air. For several seconds, it feels like the highway has simply stopped existing and the world below has fallen away. Then you realize something impossible. You are still on the road, and you are 565 meters above the ground. No city noise, no buildings nearby, just clouds drifting beneath your wheels. This is the beige Panjiang Bridge. It doesn't cross a river or a valley. It crosses what feels like empty space between mountains. A gap so deep that if you look down too long, your brain starts to reject what it's saying. But the most shocking part isn't the height. It's the question nobody can ignore the first time they see it. Who decided to build a bridge here in the first place? Because this wasn't a convenient location. It wasn't flat, it wasn't stable, and it certainly wasn't easy. This was one of the most extreme canyon landscapes on Earth. Steep cliffs, unstable rock, and weather so unpredictable that construction alone sounds like a bad idea. Yet somehow, engineers didn't just attempt it, they completed it and turned a natural barrier that once divided entire regions into a highway in the sky. But before we understand how they built it, we need to understand what they were up against. Because this canyon wasn't just difficult, it almost it was almost designed to stop them. Before any steel cable was ever stretched across the canyon, before any pillar touched the rock, engineers had to face a brutal reality. This place did not want a bridge. The canyon carved by the Beipan River is so deep that the ground below disappears into haze most of the year. And the walls on either side, almost vertical, not gently sloped like most valleys, but rising like giant stone cliffs that look cut with a blade. In most bridge projects, builders rely on the ground beneath to support temporary structures, towers, scaffolding, heavy cranes. But here, there was no beneath to rely on. Anything built from the bottom would have been too far away to even reach the top safely. So the first big idea engineers tested was simple. What if we build upward from the valley? It failed immediately. The height made it too dangerous, unstable, and nearly impossible to control precision work. Even wind alone could shift equipment at that altitude. Then they tried another approach, building from the mountains inward. But even that came with a problem. The rock wasn't uniform. Some sections were solid enough to drill into, others were brittle and unpredictable, meaning the canyon itself could not be trusted. Every solution seemed to hit the same wall: too deep, too steep, too unstable, too dangerous. At some point, most engineers would have walked away and chosen a different route entirely. But this location wasn't random. It was part of a larger plan to connect remote regions of China with faster transportation routes through mountainous terrain. Avoiding the canyon will mean longer routes, more tunnels, and years of extra construction. So instead of abandoning it, they changed the strategy completely. They stopped thinking about building from the ground and started thinking about building from the sides. From solid mountain anchors high above the canyon floor, a new phase. But this phase came with a level of danger most people would struggle to imagine. Because now, the work wasn't happening on stable ground, it was happening in the air. High above the canyon, workers began drilling deep into solid rock on both sides of the mountains. These weren't shallow holes. They had to be engineered deep enough to hold back thousands of tons of force. Because once the bridge was complete, everything, cars, trucks, wind pressure, vibration, would be pulling outward across the canyon, and only these anchors would keep it from collapsing inward. Then came one of the most delicate steps in the entire construction: the installation of the main cables. Massive steel strands, each one incredibly heavy on its own, had to be transported, lifted, and stretched across a gap where there was no support in between. At this stage, there was no bridge yet, only two mountains and a void between them. Workers used temporary guidelines first, thin cables carefully extended across the canyon using specialized equipment. Then, slowly, thicker and stronger cables were pulled into place. Every meter had to be controlled, every adjustment measured. Because at this height, even small errors could create massive tension imbalances later, and the conditions were constantly working against them. Wind rushed unpredictably through the canyon. Clouds often swallowed the entire construction zone, reducing visibility to almost nothing. Sometimes, workers could not even see the other side of the canyon they were building toward. They were relying entirely on communication, timing, and precision. One mistake wasn't just a delay, it could be catastrophic. But then something remarkable began to happen. From a distance, the canyon started to change. At first, it looked like nothing more than thin lines in the sky. Then those lines became structure, and slowly a shape began to form. For the it became a first time it became possible to imagine a road where there had only been empty air before. A highway was being born into the sky. But even as the structure began to appear, the hardest part was still ahead. Because building it was one thing, making it survive the forces of nature every single day was something entirely different. As the bridge slowly took shape across the canyon, engineers were no longer just focused on building it, they were focused on making sure it could survive. Because at 565 meters above the ground, the environment behaves differently. Wind doesn't just blow across the structure, it pushes through it, around it, and sometimes underneath it in unpredictable ways. So instead of trying to make the bridge completely rigid, engineers designed it to respond, to adapt, to move slightly under pressure rather than resist it completely. This flexibility is one of the reasons it can survive extreme weather conditions. But the real strength of the Beipanjiang Bridge comes from what most people never see: the tension system. The massive steel cables running across the canyon are not loose or decorative. They are under extreme, continuous tension, pulling the entire structure tight between the two mountain anchors. This tension distributes weight evenly across the full span of the bridge, so no single point carries the full load. Instead, the force is shared across thousands of connected components working together as one system. Then there are expansion joints built into the structure. These allow the bridge to expand when temperatures rise and contract when they drop, because even metal is not immune to the environment. At this scale, even a few centimeters of movement matters. Everything is calculated, everything is controlled, nothing is left to chance. And yet, when you see the final result, it still feels unreal. A full highway suspended in the sky, cars moving across what looks like empty space, clouds drifting beneath the road like something out of a dream. But perhaps the most beautiful part of the Beipanjiang Bridge is not its height or its engineering, but what it represents. The idea that even the most extreme landscape on Earth are not limits. They are challenges waiting to be solved. A place where impossible is not the end of the conversation, but the beginning of innovation. So the next time you see a bridge stretching across a valley, a river, or a mountain, remember this one, because sometimes The things that look like they shouldn't exist are already holding the world together. Thanks for watching. If you enjoyed this story, like, subscribe, and tell me in the comments, would you drive across the highway floating 565 meters above the ground? See you in the next video.